Hello everyone, today we're going to cover a very challenging and interesting problem, which is minimum window substring. It is very hard. It's a hard problem in lead code, which is number 70, I guess. I'll give the link for the practice link so you can go there and practice after this lecture. And I'm damn sure that once you complete this lecture, you will understand this problem very easily. So take your pen and paper and get ready with me. So first let's talk about the problem statement. So what the problem asks you to do. So what they given is they will give a two particular string. One is search string and one is a target string. So it again it consists of a list of characters, a sequence of character. So you just need to find the minimum window such that all the character from the target exists there. I'll repeat once again. So you just need to find the substring window such that all the character from the target exists here. That's it. So now let's see with example for better understanding. Now let's get back to the explanation part. Now let's see with the example, guys, for better understanding. As we mentioned, we will be given a two input. One is search string, one is a target string. You need to find the minimum possible window where this all the character exists. You can see A repeated one time, B repeated one time, C repeated one time. If you see this entire string, the B, A, and C, it is the minimum window which satisfy this particular condition, right? You can see A repeated one time, B is there, and C is also there. This is the minimum possible window. Let me, for complexity or for better understanding, let me add another A here. Again, this is also a valid string, right? B, A, and C. So it satisfies this condition. It should have a 1B, 1C, and 1A. It satisfies the condition. So why not this is not an answer? Because this, with this string itself, you satisfy this, right? So why you need to add one more extra character? So our question is, you need to find the minimum window. So you already find the minimum in this particular character itself. So why you need to find add extra character and make our problem complex? So your task is to find the minimum window, possible window. This is also a possible window, but this is not a minimum possible window, right? It's a possible window, but not a minimum possible. Just keep in mind, you need to find the minimum possible window. So now let's move to the brute force solutions. So as always, we need to find the all possible characters, right? I just written down all the possible characters. So now let's walk through it. Same typical two for loop and just generate all possible substrings. If you start from E, these are the possible substring you will get. Now let's find the substring which satisfies this condition. So we need to find T only one, right? This is our target, sorry, K. Our target is K one time. So let's see, K is there in this. Nope. Yeah, K is there. So what is the substring? EAAK. EAAK, which is of length 4. Now let's see all the substrings starting from A. Okay, is there? Nope. Yeah, it's there. And this is better than this. Is it better? Yeah. Is it because you getting at length 3 itself, where in this take it took 4 length. So now let's update the best. Now best is going to be AAK and the minimum window is 3. Now let's move to this next character and you can see AK. Again, tell me whether this is better than this one or not. Yeah, it's better. So let's update a better one, AK, and the minimum window is 2. And now let's move to the last character, which is K, which is equal to target. Tell me this is better than this thing. Yeah, obviously it's better because the size of this window is 1, whereas the size is 2. So just update the best to K and the minimum window is 1. So our result is going to be K. And the question asks you to return the particular window, not the length of the character. If they ask, you can directly return 1. If they ask you, depend upon the interview may ask you to return the length, minimum window length. But in a given question, they ask you to return the minimum substring, the minimum window substring. So for our case, just return K. I hope you just understand this brute force solution. Now let's talk about the time complexity in a different way, different manner. Now let's analyze how much time each character has been visited. Okay, so at the first step, every character will be visited one time when we compute this particular substring. starting from E till the end. So let's put mark it as 1, 1, 1, 1. Now we'll move the pointer to the A and we'll compute all possible strings. So this count will get increased by 1, right? So 1, 2, 2, 2, right? At the next iteration. At the third iteration, will start to visit from this particular string, right? So again, the count will become 1, 2, 3, 3. So at the last step, what we'll do is we'll visit K. So now the visited count or touch count will be 2, 2, 3, 4. If you don't understand what the touch count is, like how much time we're just visiting it, that's what this touch count is. So we're visiting E one time and we are just seeing A twice and this A thrice and this K for 4 times. If you compute the time complexity, like it's going to be big O of n square. It's technically you're visiting the array twice, 2 times, right? So the space complexity is going to be big O of n because we're going to use hash map for calculating purpose. So space is going to be big O of n time. It's very simple, and I hope you understand this touch time. And if you write the solution also, you can easily compute the time complexity. Obviously, we'll have two for loop where we visit each and every character twice. So without wasting much time, let's get into the optimal solution. As we discussed at the starting of the video, so we are going to implement a two-pointer sliding window technique to optimize the term complexity from big O of n square to big O of n. So it's a pretty interesting solution. So please pay attention and I will try to explain as easy as possible, guys. So, and in this particular problem, this problem, all the sliding window problem, we have two choices. One is to expand the window, one is to shrink the window. So just keep this in mind. And first let's talk about the intuition of this problem and then we'll move on to the dry run. Okay, as an intuition, like what is the first thing we need to care is we need to find the substring which satisfy this particular condition. Our target is MA. Like we need to have one M and one A in our particular string. So let's, for complexity, let me add like one more string here, MAK. Okay, let me add MAK. Now our goal is to find the substring, the minimal substring which satisfy all this condition, right? So the first step, we need to have two pointers L and R at the first starting position. Now just tell me guys whether this particular window satisfies this condition or not. Nope, it doesn't satisfy, even though it has A, but it's lack of M and K, right? So it doesn't satisfy it. Now, as we discussed, we have two choice. One is to expand the window, one is to shrink the window. Now just tell me guys whether at this particular case, what you will do, whether you will shrink the window or expand it. If you guessed it right, then that's pretty good. We'll expand the window. And the one more important thing is, very important thing, always try to maximize the window until unless it satisfies it. You need to maximize the window until it satisfies this condition. You need to find the substring which contain K, M and A. You need to find it and then we'll worry about the shrinking part. So you don't worry about shrinking part at the beginning itself. We'll care about that later on. So first our goal is to find the substring which satisfy this particular condition, guys. Keep in mind, find the substring which satisfy this particular condition. Okay, and then we'll worry about the shrinking part. Okay, when we walk through this, I will explain about shrinking part. Now let's expand this window. AK. So does this satisfy this condition? No. Again, just move the pointer. Does this satisfy the condition? No, it doesn't. If we move this particular place, it's satisfied because we have K, we have M, sorry, we have A, we have K, we have M as well, which satisfy this condition. Now let's update our best. Our best is going to be A, K, O, M. Now we need to care about the shrinking part. Okay. Now for shrinking part, just move the L pointer next step and check whether this particular substring is valid or not. No, it doesn't valid. It violates this condition. So we need A to make a substring a valid or not. So we lack of A. Now our condition is failed. So whenever our condition fail, we'll stop this shrinking part and we'll start to expand it. Now it failed, right? Because A is missing. So we'll start to expand the window again, once again. Now expand the window. KOMP. Does this valid? No, it doesn't valid. And right now, does it valid? No, it doesn't valid. And again, let's expand it. Does it valid? No, it doesn't valid. Again, let's expand. It doesn't valid. So again, let's expand. Now tell me guys, this particular window is valid or not? Yeah, it valid because we have K, we have M, we have A as well. But just see the size of this particular thing. The size is very huge. Do you want me to update the best? Do you want me? No. Our goal is to find the minimal possible window. So this window is very huge. So we don't update this best one. So now our part is to find the minimal substring, right? So we'll start our stringing phase. Now let's write the frequency of the character. So we have K two times, right? One, two, and we have M also two times, A one time. Now let's move this L to next position. Now our K become ones. Again, still it satisfy this condition, right? We have one K, we have one M, and we have one A as well. Again, this satisfy, but this length is too big, so we don't need to update it. Again, start to string the window. Move the L point to the next position. Now tell me whether this is valid. Again, this is valid, and this is not best one. So again, just move this, and don't forget to decrement this one. Now also this particular substring is valid, but again, this is not a best one. So just move this. Now just tell me guys whether this is valid or not. Yeah, it's valid, and it's also one of the best case, best answer. So KPMA. This is also almost equal to the base. Again, you can write this also, KPMA. You can write either this or this one as well. It's your choice. Now again, we need to string the window. But if we string this time, our case getting failed. So our satisfy condition is going to be K one time, M one time, A also one time. So when we move this particular thing, it get failed guys. So stop the shrinking phase, and now let's move to the expand phase once again. Now expand the window, and if you expand it, this will become 1. Now tell me guys, this particular substring is valid or not? Yeah, it's valid, and this is the best one so far, best one. You can return PMAK also guys. Now you need to worry about shrinking phase, right? Whenever we find the window, and we need to start shrinking it and to find the better optimal window. So now let's shrink the window. Now tell me whether this particular string is valid or not. Yeah, this is valid. It has M, it has K as well, it has A as well. So this particular window is valid. Does this the best one? Yeah, obviously this is the best one because the window size is 3. So now let's update the best to AMAK. Now the best substring window is MAK. So we directly return this thing, and I hope you just understand this particular explanation. So keep in mind guys, you need to expand the window as max as possible, or until unless you met this particular condition or the target strings. Until unless you met this condition, just keep on moving the window. Don't worry about the shrinking part, just keep on moving it. And once you find a substring which contain all this character, then you worry about the shrinking part. Just shrink the window and just check whether this new particular window is valid. If it's valid and better than the best one, just replace with it. Again, just move the window and check whether this particular thing is valid. Yeah, it's valid, so update the best character, and again just move it. Now if you find something unusual, like if it doesn't satisfy the condition, now what you have to do is you need to stop the shrinking phase, you need to start the expand phase. If you remember in the dry run, we stop the shrinking when the satisfying condition get failed. So whenever the satisfying condition is failed, start to expand it. So again expand until the satisfying condition passed. So once it passed, start this shrinking phase. and according to that given substring, update the best character. I hope you understand this problem. Now let's talk about the time complexity of it, and we'll see about like how much time we touch the each character also. We'll see that now. We'll take the same example as previous, which is EAAK, and target is going to be K letter. We'll see as always. We'll have L and R pointer, right guys? We'll have this, so we'll just expand the window. Expand it. It's not satisfied, so expand. We just keep on expanding it. So we'll visit every character only one time. Now we found our current substring which satisfy the condition. The condition is K only one time. Now we'll go for stringing phase, right? Now let's string the window. Now this particular substring is also valid. Again, start to string to find the better solution. Now AK is also valid. Now again string the window for better size. Yeah. Now we've visited every character one single time. One. So at max we see every character twice. But if you see this particular example, the brute force solution, we visit E one single time, and this A two times, and this A three times, this A four times. But if you look at our optimal solution, we see in this A only one single time. Sorry, this E, right? We see in this E one single time, this A two times, this is two times, this is two times. At max, you will visit this character only twice. So the time complexity is going to be S plus T, where S is going to be length of search string and T is going to be length of target string, and space is also going to be same, big O of S plus T. Now let's start to write the pseudocode, guys, and once we write that, we'll solve this problem in lead code, and then we'll just wrap up this video. So let's declare L and R pointer. Always we need to declare L and R pointer. L and R is going to be 0, 0, and then we need to have the hash map for T. So this thing, we need to build this one. Okay, so let's build this first. So let's name this as T counter. So T counter is nothing but what are the valid character you need, like how much character you need. So T counter is going to be hash map, and then let's iterate to this T, like for so character in T, we need to iterate this and just update the counter. So T counter of character plus plus. Very simple. So if you write this code, you will already build this particular thing. Now let's move on to the next case. What we did is we will have another map to check the current window. Let's declare the S counter. S counter is to keep track the current window, how much thing it has, and we'll also have the variable formed, which will keep track how much letter is formed. So formed is going to be initially set to 0. And now let's start the while loop. And before that, let's have the best. So best is going to be empty string, and we'll start the while loop now. While R is less than N, not N, sorry, all is less than S, length of S. Now, as always, what we'll do is we'll just update the S counter. So S counter is going to be of S search string of R plus plus. So now this part tells that we just expand the window, right? Because we just adding this to the current window, this character S of R. This is expanding phase. Now let's update the formed one. So formed is nothing but like how much character is formed. For example, in this particular window, the formed is going to be 3 because we form A, we form M, we form K as well. So to keep track of form, we have variable, right? We have a variable. Now how we need to fill this is it's simple if condition. If character in T counter, if this in a T counter, and the frequency of the character is equal to the S frequency. S counter, I mean what I mean by character is this particular thing. Okay, I will just rewrite it. S of R. If this counter is equal to T counter of this character, then we can increment the formed one plus plus. It's very simple, right? Now after doing all this thing, we need to write the shrinking phase, right? This is expand phase. Now we need to carry up this shrinking phase. So what is the case for shrinking is while left is less than or equal to right. This is a small base case, and what you have to do is formed is equal to length of t. It's pretty simple, right? If this condition pass, which means we have a valid substring. Now what you have to do is we need to string the part, right? For stringing, what you have to do, we need to move the character. Before that, we need to check whether the current string is best or not. For that, if r minus l plus 1 is less than the length of best, if it's better than the best solution, just assign it to the best. So best is going to be s of l to r. And then what you have to do is we need to string the window. So let's store temporary variable. Temporary variable is going to be s of left. Now just move the left pointer, left plus plus. Now after incrementing this window, we need to decrease the s counter, right? So s counter is going to be temp minus minus. So, and right now what we need to care is about the formed status. And if you look back to the example, so after finding this particular window, right, what we did is we cared about stringing phase. So we started to string it. So what we did, we just move L to this next particular position and we check that current substring is valid or not. In our case, it's not valid. So we stop this stringing and we just move to expand phase. How do you find that is? It's pretty simple. If the temporary in t counter and the frequency is less than the required, once again the required frequency, which is t counter of temporary variable, is less than the s counter of temporary. Whenever this condition happens, we just decrement the formed. So formed is going to be minus minus, and that's it, guys. And just close this one and don't forget to increment the r pointer, and just at last just return this best variable. That's it. It's very simple solution, I guess. Now let's code this up. So this is a lead code number 76. You can go to this problem. I'll just give the link below in the description. You can check there. Now as always, we start with L and R pointer and then we'll declare T counter and S counter, guys. So L and R is going to be 0, 0 and T counter is going to be default dict. You can, in your own language, you can use whatever you want. But for me, I'm using default dict, and then I'm going to have s counter as well. S counter is also used as default dict. And now let's build up the t counter, guys. Now let's build it up. So for character in t and s counter of not s. Now let's build this t counter, guys. So for character in target and t counter of, I'm just doing spelling. Okay, fine. T counter of character plus equal to 1. And then we need to have formed variable, right? So formed is going to be 0 initially. And what is the required? The required is going to be length of t counter. So required is going to be length of t counter. Because let's say ABC. So what is the required amount of thing? You need to form 3 character. That's what required is going to be 3 t length of t counter. And let's say A, B, B, C. So now what is the required count? It again, it should be 3. You need 3 character, but the frequency may be different. But the number of unique characters is 3. That's what this required tells. Required is going to be length of t counter and formed is going to be initially 0. Now what you have to do is we need to have the best starting, which is best L, and then best R. Initially we'll set to the 0, 0, and we'll have minimum length. So initially minimum length is going to be int max. So in Python we'll use float of integer, float of infinity for int max. This is how we use int max in Python. In CPP we can have int max directly. The reason because initially we need to set as int max, we cannot set to 0 because we need to find the minimum window itself. 0 is always minimum, so we'll always start with float of maximum only. If the question is maximum window, this will be negative int max, negative infinity. So that's why we'll start with the maximum possible number as the minimum length. Now let's start the while loop. While r is less than length of s, if you remember carefully, the step 1 is going to be expand the window. S counter of char plus equal to 1. So the current char is going to be s of r, right? Now we need to check the case, formed case. If char in t counter, if it's there, if it belongs to the t counter, and if it find the exact frequency, like t counter of character is equal to s counter of character. If we find exact frequency, then we formed one particular character. So formed is going to be plus equal to 1, and now we need to string the face, right? So when stringing can happen, tell me guys. Simple case, if L is less than or equal to R, this is a simple base case, right? If L is less than or equal to R, and formed must be equal to the required. So formed is equal to required. If this condition pass, which means we have some kind of valid substring which satisfy this given condition. And after finding this, we need to string the face, right? So before that, let's see we got best result or not. For that, let's have the current window is going to be R minus L plus 1. If the current window is less than the minimum length, which means we found something better than the previous one. So just update best left is going to be current left, and then best right is going to be current right, as well as the minimum length. So current minimum length is going to be current window. Now we need to shrink the window. Simply s of let's say temporary. So temporary is going to be s of left and s counter. So s counter of temporary minus 1. We just shrink the window. After shrink the window, we need to check if this condition violated or not. So let me copy this again. I'll just put it here. So instead of character, let's replace with temporary variable. If the temporary variable in the counter, and if something violation happens, we need to just remove this formed character. If the required counter is less than the having, for example, let's take this example like we need two A's, like T is going to be A, B, and the current substring as, let's say, A, C, A, B. Right now, if you see, we just got some valid substring, right? We just got some valid substring, and we'll just move this A to next particular position. Now, if you see, the counter of A becomes, right, like the required A should be 2 and B should be 1, but our S, like after moving this particular character, A becomes 1 and B becomes 1. So it violates this condition, right? The formed condition has been violated. That's why we just decrement the formed by 1, and after coming off, we just increment the left by 1 and we just increment right by 1. And again guys, if you don't like while loop, you can simply use for loop as well, because you don't want to do this thing. And sometime I used to forgot update the right pointer. At last I'll just end up in the infinite loop. It's again your wish. And then at last we just return the answer. Return empty if the minimum length is equal to int max. So when this condition occurs, like when you don't find the given target in the search string, at the time we'll have infinite variable. If not, just return s of best left and the best right plus 1. Now let's run this and see. Yeah, it passed all the test cases. Now let's submit this and see. Fingers crossed. I hope this will pass. Oh, we just passed the test cases. I hope you guys understand this problem very much. And I'm sorry, I think I might take you a lot of time, but this is very hard problem. I need some time to explain to you guys. So we'll meet again in next video. Until then, keep watching. Bye.